All right, so in the first part of the lesson, we discussed the equation of a line, and that has led us into part two of the lesson, the difference or defining what a partial and direct variation are, and outlining the differences between the two. All right, so they both obviously have to do with the equation of a line. They both obviously have to do with linear relationships, since they're a part of section 4.3. So that's what we're going to be discussing, this idea of something to do with a linear relation that makes it a direct variation and a partial variation. Right? So I'm going to take you through some of the points of what a direct variation is, and then we'll look at what it looks like as a table, what it looks like as a graph, and what it looks like as an equation. Right? And we'll do the exact same for partial variation. So direct variation is a relation, a linear relation that is in the form that we are aware of now, y equals rate of change times x, or y equals m times x. All right? Now, remember I said that the m is the same thing as rate of change. Okay? Notice that there's no initial value here. Do you see that? There's no initial value, or there's no b value in this equation here. So no initial value there, no b value, plus or minus b, or plus or minus initial value. So that is a big thing here that has to do with direct variation. So the graph of y equals mx, and by the way, when I say no initial value, that just means 0. So it has an initial value of 0. It's not that it doesn't exist at all. I guess theoretically it doesn't, but if you had to give it a number, it would be 0. The graph of y equals mx is, of course, a straight line. It's a linear relationship with just a slope of m, and again, no initial value. All right? The line, because the initial value is 0, that means that the line, if we were to draw the graph, the line has to pass through the y-axis at 0, 0. Because the initial value is 0, it has to go through that point of origin. All right? And so if we look at the graph, because I think that's the easiest one to look at. So let's look at the graph first, and then I'll look at the table of values. So the graph, you can see the line has to go through 0, 0 in order for it to be a direct variation. And that's it. That's how you really can distinguish what a direct variation is through a graph, is just take a look at whether the line goes through 0, 0. You know, if the line were doing something like this, that would not be a direct variation because the line would not go through the origin 0, 0. All right? The next easiest one is probably the equation. So let's look at the equation next. Notice that the equation would just look something like y equals 10 times x. So it would be in the form of just y equals rate of change times x, or y equals m times x. Remember, those are the same thing. Okay, so it would be a number for the slope or the rate of change, but there would be no initial value because the initial value is 0. Okay? In a table, what would it look like? Well, you are looking for, wherever there is a 0 for x, there has to be a 0 for y. That's what makes it a direct variation. If that y value was anything other than 0, it would not be a direct variation. Okay? So in a table, look for the value of y to be 0 when the value of x is 0. So you have to have that 0, 0 in the table of values. That's how you know, okay, I've got a direct variation example. All right. So those are the three ways to look for it. In a table, look for 0, 0. On a graph, look for the line to go through the point 0, 0. And in an equation, look for an equation that does not have an initial value. Okay, so it's missing that initial value. It just says the rate of change times x, and that's it. All right. So obviously, moving on to partial variation, it's basically the opposite of everything we just talked about. Okay, it does have an initial value. So it has a rate of change and it has an initial value other than 0. And if you were to write it in the mathematical way, the equation would be in the form of y equals mx plus b. Okay, so there would be a b value there. Okay, it does not pass through the origin. If there's a b value, okay, it will not pass through 0, 0. It just won't. Okay, because of that b value. So the graph is either going to be moved up or down from that origin. Okay, so again, let's look at the graph. All right, so how can you tell that we have a partial variation? As long as the line does not go through the point 0, 0, it's going to be partial. So in this case, it goes through the point 0, negative 10. That's my coordinate there, x and y. Okay? As an equation, it is going to actually be in the form of y equals rate of change times x plus my initial value. So there'll actually be a value here. Now in this case, it's negative 10 or minus 10. That means we move the line down 10 units. And that's from the origin, which is exactly what we did here in the graph. Okay? And then lastly, in a table, you are looking for wherever there's a x value of 0, you're looking for a value that is not 0 for y. All right? So you're looking for a value that is not 0 for y. So let's make a note on that. So where there is a 0 x value, look for a numerical value for y other than 0. Okay? So for direct variation, you're looking for 0, 0. For partial variation, you're looking for 0 something other than 0. So 0, 5, 0, 1, 0, negative 5, 0, negative 10, and so on and so on. All right? So that concludes this lesson describing to you the difference between direct and partial variation. There's plenty of questions in the homework that deal with this. You now know what direct variation looks like in a table, in a graph, and as an equation. And you know what partial variation looks like in a table, graph,